So now we're going to start section 11.7. 11.7, we're going to talk a little bit more about our counting principle that we saw previously, and we're also going to talk about permutations. So remember back in section 11.4 when we were talking about tree diagrams, we talked about our counting principle. It says if our first experiment can be performed in m distinct ways and the second can be performed in n distinct ways, then the two experiments in that specific order can be performed in m times n distinct ways. Right, so we use multiplication when we were the operation of multiplication when we were thinking about our counting principle and how many different ways that we could have results. So we're going to use that idea in this first example where we're looking at passwords. A password is used to gain access to a computer account is to consist of 2 lowercase letters followed by 4 digits. Determine how many different passwords are possible if repetition of letters and digits is not permitted. All right, so what I'm going to start by doing is just make little spaces here, right, for each of my different digits that we're going to be looking at. And then I'm actually going to do this for all of these because all of these we're going to be looking for a password of 6 digits. Okay. All right, so in our first case, repetition of letters and digits is permitted. All right, so our first two are lowercase letters, so that's going to be kind of just represented underneath there by the letter L. We have 26 letters in the alphabet. Repetition is allowed, so we have all 26 letters to choose from for each of these. All right, then the rest of these are going to be digits. If we count the digits 0 through 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that actually gives us a total of 10 digits. Right? So 10, 10, 10, and 10. Again, all the same because repetition is permitted. So then we're going to multiply these together. We get 6,760,000 possible passwords. All right, now the only difference between A and B is that in B, repetition is not permitted. All right, so we're going to start with our letters. We still have 26 letters to choose from for the first digit of our password. But then the next one, we're only going to have 25 because whatever letter we picked for the first one, we can't use again. So we're keeping that letter out. We only have 25. For our digits, we have 10 for our first one, right? Because we can use any of our 10 digits, 0 through 9, excuse me. But whatever we use the first time, we can't use the second time. So then we have 9. Well, now we've used 2 digits. Right? Let's say we used 1 and 2. That leaves us with 8 digits. Well, now we've used another digit, so that leaves us with 7. So each one of these, we basically go down by 1 each time. We multiply these, we get 3,276,000 possible passwords. Right, so a big difference. We've cut out about half by eliminating repetitions in this particular example. All right, then for C, the first letter must be a vowel, and the first digit cannot be a 0, and repetition of letters and digits is not permitted. All right, so if our first letter must be a vowel, we have 5 vowels to choose from, A, E, I, O, U. Right? Repetition is not permitted, so that means whatever we use the first time we can't use for this next one, but we're not limited to vowels here, so we're not going to go down to 4. Instead, we're going to think about what we did in the last example, how we went from 26 to 25. The only difference is here, we went from 5 for the first one, we used one of those, and now we have 25 other letters left, either vowels or consonants. Right, the first digit cannot be a 0, so that means we can only use the digits 1 through 9, so we only have 9 choices. Right, and whatever we picked, let's say we picked the number 9 for instance, well then we can use 1 through 8, but now we can use 0 for this one. So we're only eliminating one digit here. So we have 9 to choose from. Now we've used a non-zero digit and a digit that could possibly be 0, but it's not the same as that one. So we've used 2. So that means our next one is going to have 8 choices. And like in the last one, our last one is going to have 7 choices. We multiply these together. We get 567,000 possible passwords. So when we're thinking about and using our Counting principle, we need to make sure we're paying attention to whether or not things can be repeated and or reused, or with replacement, without replacement, those types of things that we've seen also in previous problems.